Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. Today, we're gonna have some kind of little nuances where I think it's right besides us, there's some construction stuff happening, and yeah. So if you listen to some kind of that, uh, please forgive me, but I cannot do anything at all. So I hope that all this, besides that, goes well, and that we can make a fruitful stream. And yeah, all right. So please, if you would like to follow along, feel free to ask questions whenever you want, and I'll be happy to answer them. What I think, well, let me open for Coder first. And if I remember, we were doing this kind of intro to dispatcher state, what basically is going to work as our intermediary as to the way to handle the whole dispatcher state as it goes, you know. And I mean, probably, I mean, this is really kind of a basic thing. We will continue to add more stuff here, more functionality, and see how it goes on, you know. So, for example, let me see if I can go to the place where we were using it. Here you go. And probably the thing that I want to do before anything goes crazy, I would like to pass this 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 data or this dispatcher to its own file just for cleanliness. So I would like to create EagleFly tracer .cpp. And I will basically copy the whole thing that we were doing, that I believe, well, let me pass this also. I don't know what this is, the exe path, that can stay there, I guess. That can stay there. And even though that, well, both, I mean, this data, it pertains, or it's from the Win32 platform layer, you know. I just want to divide it so we have like same cleanliness thing. So let me see, do that, and there you go. So now we have our own EagleFly tracer, and we should also, why not, EagleFly tracer.h. Now we pass the structures that we were doing before. So yeah, I think we can start doing this. And since we are going to use these APIs, for example, all this stuff, probably what I like to do, well, I can include it here, yeah. Okay, include EagleFly, tracer, no, probably here. Well, parse Win32 EagleFly.h to see bottom key. What's that? I don't know. I have no idea. And for now, we're gonna keep it here. Probably gonna do this. Where is the string length defined? It's right there, so probably what we want. Concat strings, all this. Probably want to pass them to the platform layer. Let me see. I can put them, I guess, right here. Okay. So now we have our isolated Win32 tracer. In fact, I don't know if we should call it Win32 EagleFly tracer. You know what I mean? Since that's what's basically is, because it's platform dependent. That's the thing I'm like concerned about, you know, like thinking of, okay, whenever we want to do the debug way, or the debug, the Linux platform layer, how are we gonna divide all this stuff, you know? Because basically all this is platform dependent, so you'll need to do the same thing but for Linux. So I mean, we can have like some kind of this some kind of preprocessor thing going on there, so we can have one just file and that makes the tracer itself, and depending on the platform, it just goes in and out, you know. That can be one route, and probably that's the best thing, I guess. I mean, it's not the best thing for readability, but well, I mean, probably yeah. If it's I mean, if it's like really well organized and stuff like that. So yeah, I mean, I don't have any problem with that. It's fine. So we'll leave it that way, I guess. And so yeah, let's continue with the thing that we left off. The last thing that we did, I believe, was that I'm sorry. I remember it was something like oh yeah, well, we finished with the get thread from ID mapper. So we have this mapper that basically gets us, it's a linear mapper, well, yeah, it's inline mapper, where we basically have a table of entries, ID, ID handle threads entries, and we just keep going. We find something, a case or a bucket where we can insert it, we insert it. If not, we go linearly till we find a bucket that we can insert the pair, you know. So I think that works fine for now. If we see that we have like a bunch of it, and I don't know, we want a burst search, which I don't think. It depends. We can improve it, of course. So yeah. So now the thing, we have that, and we can print it out, you know. Now the thing that I was looking for is like, okay, my question is, how to, I mean, since we know that debugger, the process is being debugged, the debugging, works as, how can I say, I mean, we already set ourselves with this continue debug event, that basically should continue processing events, you know, after each one. But what we see basically is that, okay, it's gonna right now what it does is it handles some signal states that happen, you know, like well, probably this is wrong, isn't it? Because we're waiting here infinitely to see if we have it. But let me remember what wait for the bug event was doing for us. Let me see. waits for the debugging event to occur and a process being debugged. The operating system did not output strings by output debug string and instead only output ASCII strings. To force output debug string to correctly output Unicode strings, debuggers are required to call wait for debug event ex. Okay. Oh yeah, I remember. I mean, something that's missing. I mean, besides the thing that we are like going infinite on it, which probably we can modify, but it depends. But uh, the other thing that we have to handle is all the exceptions that are being passed through it. Because right now, well, and that's the reason that we probably want to finish to process all this stuff. So I think that I'm gonna do that first, and later I'm gonna pass to the the exception event, which is the most complicated one. So with the exception event is the one that we pass it and we say whether this function continue debug event. We have to change the status depending on what the exception happens to be. Because if I do remember, there was an exception. There wasn't a continuous status that was something about do not process exception or something like that. So we should do that specifically. So let me see if I can do that. So let me first. I will. We know that we are processing the exit frame. The load DLO, I don't know how we should process itself. I mean, we should know, of course, that some DLO is going on. What? So yeah, I mean, something is like there was something that was before, I guess. I mean, right now we don't have any kind of we don't know what's gonna be there, you know. I mean, because since that, I mean, that's information that the linker puts into the PDV and the object files. So I mean, that's probably, I mean, even though it's useful to find out what data is there, my question is, could we go other route, you know? Because right now, I mean, right now it's not totally necessary to do that, but I mean, I just wanted to know what was there, you know, because it was like, well, if there's a debug, I mean, there's an info file, you know, there's something there that has debug information. Uh, it's like, okay, what's there, you know? And I see that it's, yeah, it's all the same. It's basically the PDV, you know. I mean, the PDV, or it's all the data, the symbols and types information for the debugger, for Visual Studio Debugger, which uh, yeah. So this is the size, the image name. This is the DLL, isn't it? Yeah. So this is the size of the debug information in the file in bytes, but there's no debug information. Okay. The LP image name pointed to file name associated with the H file, and that's something probably well, I think we should once we like advance on the project and see how, I mean, what information we basically need from the image or from the process that we're running into. Yeah, we will like have more clearance of what does, I mean, what do we need, and if we need to parse this kind of data. Because if you think, I mean, I mean, it probably is, probably isn't, and that's my concern, because it depends. I mean, shall we let the use? I mean, we don't want to depend too much on this kind of information, because it probably is not, you know, and uh, we should, if there's a way, of course, to handle this data without PDVs or any other kind of the same information, we should do it, you know, and that's the route, you know. So let's see. Pointer to the file name associated with the handle file. This member may be null or may contain the address of a string pointer in the address space of the process being debugged. And you know, I mean, yeah. Now that I think about it, well, we'll need the hmm. Mm, I was like thinking, well, I mean, well, why do we need the image name? Because if we're already attaching to it, we already know the image name. I guess. Well, that's in one route. But if you are trying to attach to a process, so yeah. But for example, that was the other way. You know, if we were attaching to the process, will never provide this information in the case of that. So we'll never get that information from the image thing. But the thing is, like, okay, we should know that thing before even like trying to touch the process, I guess. I guess. Because there was this kind of So I was thinking like, well, how do we want to process all this? Because right now we have this value pair thing where we were like mapping up the ID and the handle to the thread. Now I see that we have a problem because since if we leave it that like this, we have multiple handles to the same ID. Whenever we try to find and return one, it will return the first one. It won't return the one that we want, for example, because we don't have enough information for that. So I think because this assumes that they are all unique, they are not duplicates of IDs and ID, yeah, duplicate IDs, So let me see. So so yeah, the identifiers have to be different, So probably what we want is, instead of using the ID, we can choose to do something like this, In this way, we know that everyone is going to be unique, at least on the process state. Well, I mean, it can be called ID, but for not confusing the ID with this ID thing, we can call it base address, because since we are gonna have like a bunch of handles and a bunch of things, we want like specific my question is, are these handles living on process space? Let's inspect it. Okay, so here's the important thing. The debugger should not close these handles. This debugging event does not occur if the exiting thread is the last thread of the process. In this case, the exit process occurs instead. when a process exits, the system automatically unloads the process DLLs. But does not generate an unload DLL debug event. So yeah, I mean, we're gonna just receive unload DLL when the free library is there. So I think that's kind of best, I would say. RIP. Jesus. So this RIP event, let me see what we can do with that. Jesus. Okay, so there's a whole bunch of stuff that we can do there, and I guess that for now we should just print it out. I mean, we could set the error mode, but I don't know. You know, when a process being debugged as itself, it's control. Yeah. And let me see. For now, I'm gonna put this, and I'm gonna put to do uh, mm, mm, mm. And let me do basically the same with these things, because it was a whole purpose. The process, let me see, this is gonna be DLL loaded, DLL and this is like this, and this is so let me put it here, because I wanna, so basically, I mean, that means that we don't need to do this at all, probably, because the continue debug event is gonna do it. So we should not close any handles being returned from the debug application. Continue debug event will close them for us. Alright, so yeah, that's important to know, because so we don't need to do this, and we don't need to do this, and now we have to, it was the process and the thread, which is fine. And you know, I mean, probably well, these are not exactly the same ones, because, well, now that I think about it, these are from processing flow, so they are different from the ones we get from here, you know. So yeah. So what I was thinking is that we probably want some way, some structure to store all the handles, you know. We don't want to free them, of course, but we want to keep them alive, you know, every time we do that. And we can do that pretty much the same way, you know. The thing that I was looking for is that to use the object, create an object handles and returning them to the caller, maintaining resource quotas, object interface, and Okay, so handles refer to the same object but has different values. So let me see. So probably what we want So right now, well, that's kind of interesting. I mean, looking at this, what I can see is that, well, for now, I think that the only handle types of handles that we are gonna manage are basically the ones that we are getting right now. You know, like the process and threads handles that they are gonna be. I mean, we don't need to erase them, but we have to cache them at least. I don't see anything here. I mean, probably we can use more, but we can see. So let me think. So I basically do that. So what if I do something like this? I want to say something like that, and this I believe has, here you go, this thing. I want to store that handle. And probably I want to say I want a way to get it back, you know. Well, a way to read from it. It can, I mean, we can do something like the name. That it was basically this. But I remember that probably this was not valid, I guess, most of the time. So let me think. Because I mean, the thing that I'm like kind of trouble seeing is that we have here, I mean, we have a unique identifier, you know, right here. So I mean, with basically with this part, with the edge file, we can uniquely identify. Now the thing is that how do we want to catch them? I mean, how do we want to get it? What should we know about it to get the handle itself, you know? Because we can say something like, I don't know, if we want to unload it and say, I mean, this is just a test. We probably we don't want to do this right now, but if you want to say some weird find for table, and this is gonna be, let me see, for example, we have the base address. So we can do something like this. And I mean, I'm like kind of thinking here, like how can we do it, you know, because I mean, and that would be, I mean, if we do this, I mean, we map it to the address space, you know, so give me the handle, get handle from table, get a handle from table, the address, and we get a handle valid, so we can do it. But let me think first of all how are we want to use it, because we don't know exactly how we're going to use it. So let me see. See the deal loaded, and we have the image name, because I mean right now I'm talking here like, oh yeah, we're gonna use this handle, but I mean probably we are not gonna use it either. I mean, we don't know. I was thinking, well, how would we want to store it, but I probably am like, I don't have the enough data to answer that question right now. So probably what we like to do is to continue doing more usage code. I'm just gonna print this out, you know, and I'm gonna think this later because I don't know. So let me I'm gonna do this basically for everything, and I think that's it, isn't it? Good. Okay, so for example, for this one, what I would like to print would be no, the image, no, I would like to print probably this DLL blah loaded at blah. Oh, this is like this, something like this, I guess. For now, I think, I mean, we have a bunch up there, but yeah, we just want this. I don't want that, I want this, I want this, and I want this, and I want this, something like that. That's for the loading, and the same for the unloading. It would be pretty much the same. So probably we can say and this is unload DLL on, and we just have the base of the DLL, in this case, and we have to get the handle, which could get it, I guess, if we do basically the same that we were doing before. Well, I can call it ID, I guess. And I can do something like that. This should be something like this. And we have, I don't know if we can do it more like this, which basically, I mean, we can get the same value for a different base address. It could, I mean, it has some sense, I guess. So now I'm gonna do it this way, and then I wanna change this thing that we were doing just to handle it this way instead. So the loaded, this is on load. This I'm gonna win32 get from ID, and or probably this is more like win32 get handle from ID, win32 get handle from ID, and let me go right here, and basically I want to copy this. There we go, and this is going to be base address, basically this. And this stay, there you go. And this I wanted to do basically the same. Instead of doing the free ID, I wanna get it from the base address where it's gonna get executed. So I want to, here's the create thread, and I don't know why they have this like R here. probably we want to move this. Let me move this back here. We have the output debug string right here. There you go. We can have it just like this to order them, and then I can here get the handle and the threaded, I believe. Instead of doing this, I want to process the create thread. That's basically a create thread. The create thread itself has some data that we want. That is the thread local base store address. This is the one that we want. There you go. And then we want this as a getter. This is gonna be this. And this is gonna be, I believe, exit thread, and this just got the Etsy code, which that was the problem because we got the ID and that was it. So we probably well, it's gonna be bananas, I guess, because it's gonna have IDs and addresses being like the thing to identify. So yeah, no, I mean we don't care too much because we could well, for now I'm gonna keep it the way that we had it before. It's basically, let me go, this was like this for ID, and I want to cast this back to this, which is basically the thing we want. And this is a thread ID, and this is the thread ID again. But now I don't think it's gonna work, because if we are using the addresses and IDs as a mix, we are not gonna get it. And this is, so yeah, we have to explore more to see how we really want to do this. I like the memory index way, but we had to get a way to get it, you know. I mean, right now the usage is not the thing that we want, so that's not representative. So yeah, so probably this is gonna be this. this is where we see this. And this is, we have a format argument 1 format string, because this is a handle and we want that to be a handle. Okay, so we probably want that. And this is the same. These are the same. Okay, so I mean we like pretty much we just print everything in it, everything there. So let me see what we got, you know, so we can continue. I don't have any breakpoints. Oh, because it's now open file. When I want to open file, here you go. This is the tracer. Now we don't have any breakpoints here, so let me debug tracer call back right here. And also I want and also well, I want to do something before that, and is that well, yeah, I mean I'm gonna do it right now, but it doesn't matter. Okay, so I wanna set the breakpoint here and here and basically everywhere. Just to see what's going on. There you go. So if we run, we first create a process, we don't handle that. We load the DLL event, which basically tells us about the buffer is going to be the address at that address, basically. DLL blah, load address blah. Okay, F5. We have another load DLL debug event. We have another load DLL debug event. We have an exception now. And we should handle it properly, but we don't do it right now. So then we have the output debug string, then we have a load debug event, another loading, then we have another loading, then we have an exit thread, Oh, very cool. We have our next thread, and then let me see what we got there. Buffer itself, thread, we don't have the address because we don't have it loaded any thread at all. Say we code 0, okay. And then we can F7, 5. Okay. We wanna create a thread with the, we can go okay, so that's perfect. And I thought we got something printing here, but no, we don't. So probably, okay, that's good. So now it comes the fun part, okay? Now it comes the real handling of it. I mean, we just like have the thing, we know that we like, if we go to the output, I mean, we load several DLLs, we print the output debug string, we got some thread that exited, we have some, well, these are all the threads because these are not, these are the debugger threads, and yeah. So probably we want to like have a more order here, but you know, it's getting somewhere. Okay. Okay, so we're getting somewhere here. So now let's try. And let me just do this because why not? Let me create thread debug event. We probably want to basically do the same thing. Debug event. Div thread ID. Let me start by of debug event. Let me go to create thread. The tree and address. So we have right here, and this is the first one, then this ID, and then is the address. There you go. And we can do exactly the same with the create process. So let me see what we are getting on the create process, because we haven't done anything with that. Where is it? Create process, here you go. And we do basically this, and the create process has more data into it, so we can, oh no, where is it? It's a thread. Here you go. In the create process, let me go into it, and we basically want everything here: the file, the process, the thread, the base of the image, and the store address, and the image name if we have it. So let's see, we can do something as process blah id blah created starting address blah. We have thread blah, and we have the process, the file blah, we have process file thread, and the base of the image base. Let me put this, and now we have the image base, and then we have the store address, and I think that's it. I think that's good. So we have to basically get this and do this. First is going to be the edge process, then it's going to be the ID, and this is the process ID, and then it's going to be the edge file, and then it's going to be the edge thread, and then it's going to be the LP base of image, LP base of image, and then it's going to be the starting address, that's LP store address, LP store address, and there you go. Okay, you can compile that. You can take that back. You can do that. We don't need this right now. We can do that. And this is typo. Here is missing this, and this is this, I guess. because all our addresses. Just the second is not okay. So we have the store routine, and that's the tree. So this is the start address from the store routine. That's the callback or the function pointer, and this has this, so this is like this, and yeah. Alright, and now before going on, I would like to go to the exception one, well, why not? F5, have a create process, and we don't print it, of course, because forgot to print it. So we'll have an output debug string here. We should have one per call. There you go. There you go. We have process blah, on the ID blah, created file blah, thread blah, image base blah, starting address blah. Alright, if you see, it's not the same. Oh, okay, you can look here. The image base is before the starting address, so that's pretty nice. Okay, we got that, that's perfect. We can F5, process blah, created, and the thread and the image base. So this is important because if the image base is before the starting address, that makes sense. Zero exit blah blah blah, starting address of blah blah blah. And the only difference it's 1360, so it's like about, well, if it's in hexadecimal, it's in hex. Okay. Dealer loaded. We have an exception. And here we can look at the address of the thread and this address, For example, this is 98. These are the totally different threads, which is nice, or which is okay. This will be expected. And the storing address is going to be, I have no idea. Well, this scratch, and I don't know, storing address of the process. This, yes, it's totally different, and it's way much upper than the storing address of the process, which is fine, I guess. And we have I don't know, but I think it's the same. Now it's running. We cannot stop it right there. Okay, so there you go. We basically printed everything that we could from basis, you know. And now we can go to more deeper concerns, you know. So let me see. The first thing that I would like to do is to basically handle the exception correctly, because that was that was the thing I was looking at, and I was like, oh man, I have to change this, man, I have to change this, but now I'm gonna change it. Okay, so this is the exception record, and the blazy. I'm gonna continue debug event. We have that. I wanna set, I mean, I'm not gonna do this, but I'm just gonna say something like this. Continue status is gonna be that in this case. And there you go. Let me see if that does anything special. Let me go this way. So I want to go F5, we'll create a process, reload the alert, we got an exception, and we have a continuous status, and continuous status it's C55538, and this is going to be now F10. Continuous status now is something totally different. We continue. Output debug string 5. We have a load DLL, load DLL, load DLL. We have a create thread and the starting address. Add sync blah blah blah. So everything's the same, isn't it? But now we have a tipping point, which is nice. Okay. Or I don't know if we already have it, but I think now it's better handled, that thing, which is the thing that we want. So let me see. Now let's continue to going deeper. So the first thing that I would like to do is to have a way to to continue processing stuff, because right now, I mean, the only thing that we got, and I mean it's cool, but we want to handle more. We want to a certain way to I mean, because the only thing that happens is that whenever we create a thread that's gonna be processing this stuff, probably this is not the thread. Probably the thread that it's gonna do is this one. But you know, it it doesn't matter. I mean, the point is that it finished initialization because that's the only thing that we have gotten right now. Initialization stepping, because every time initialization stepping goes, we got signals from the process. But now it seems that whenever the last thing of part of initialization for the process ended, then we don't get any more signals. So the thing that I want to do is to get more signal in there, and the first thing that I would like to do is for that is to stop the thread on the first element, on the first, let's say on the first instruction, you know? And I think because that's what we would like to, I mean, for basis I would like to start doing that, you know, stop on the first instruction, get a signal, and say, it's like, I mean, the basic thing of a breakpoint, for example. So basically it's like we're gonna do a breakpoint in the first instruction so that we can inspect it and we keep processing each one, you know. So let's try by doing that specifically. So let me see. For that thing, I say that we probably want this and this and this gonna be so yeah, this was a problem. We were not, since we were passing continue when they got exception, but we didn't handle the function stops all exception processing and continues the thread, and the exception is marked as handled, which I mean is the ideal thing if we process it, but if we don't process it, we should do something with it. So probably what we want is something like something like this. And then I would like to check for the exception that what's been set, and we want to check for exception breakpoint, I believe it's called. I don't remember. Break. We got a breakpoint there. Let me see. Now I can go directly. So for a breakpoint, and this is interesting because for a breakpoint it's going to be kind of tricky, and the reason is that, well, the first thing that we have to do is to find out the starting address of the process, you know, and we know that because that's in the please, sorry, I do not need your help right now. Please, I don't need. Okay, so we know it because it's right here. It's basically a process debug event, and we can, no, sorry, create process. We have here basically is the LP store address, and LP store address let me see if I can go. Probably is base of image. Let me think. Let me see. So the first thing I would like to do is to open I can go msdef and I will go test debug target.exe. Build, and this is gonna be I don't know what exactly, but probably right there. And then we can open the file. and we can and I will press F10 to see what happens when I run this. You know, that's what we want to expect from this, to enter at this entry point. And if I go to the disassembly, we should look at this, all this. Oh, I mean, do you see all the whole code here? Like, what's all this? This is return. This is totally crazy. But I mean, here you go. I mean, these are the basic instructions, and these are the code paths that basically have to be moved. So what we want to do is to insert a breakpoint here, an exception that basically something that tells we have to remove this instruction basically, and insert another instruction so that the processor can say that, hey, we don't want to process that instruction, we want to process would say like an exception, you know, in Windows for example, but it's more like it's a lock. So we want to put a lock, an interrupter, and tell you, hey, this is a debug interrupt, please stop execution. Once we do that, then we change back the instruction that we want to execute, so we could execute it, you know. And that's kind of tricky, because if we are already in that address, we are not going to execute that instruction. But hold me here, because probably we can do that. We can handle that. Nope. So yeah, at least we know that these are the code bytes: 48, 89, 54, 24, and this is the address of that instruction. We shall know if it matches the ones that we were looking here. No. There you go. So it's a little bit less than the entry point we got from the thread. So if I run EagleFly again, or I believe I have it here, we have the process. Well, the address is gonna change, I believe, because this is the string address, and this is the image base. Part of this is this is closed, isn't it? And the string address. What? There you go. So it's kind of crazy, because the string address is not it's passed before that instruction, and the image base is a little bit before that instruction. So yeah, And where is it? Does it look target? Well, at least from the place that I see here, because probably it's not here, probably it's more here, because 6636100. So they're like even segregated. There are instructions that are in some places, but they are not contiguous in address space, which is interesting. Do you see? There are these instructions at this address space, but they are not several ones. There are gaps everywhere. And then they have this. There are a lot of instructions, blah 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 blah. We have all this craziness going on. So yeah. So let's see. I hate these pages. Okay, so I think that sets us good for today. I would like to stop here before going up onto deeper on the breakpoint thing, because we don't have much time left. So I'd say that we would do that on the next stream. And for now, we're just gonna set it as what we got, which is fine. Alright, so thank you very much for coming up on this stream. If you would like to ask some questions, please feel free to ask them. And yeah, so yeah, today was a little more kind of a implementation research thing. And yeah, so for the next one, we'll try to set that breakpoint and to inspect directly the data. So yeah, I think that's good. And I will see you all on the next stream.